Today it will be a quick stream. We're doing the quick sort. So let's go. Let's dive into this. Programming. So this was our merge sort, I guess. Yeah, let's go. Boom, boom, boom. We don't need this one. We have to open actually a new project quick. Today everything is quick because we're going for the quick sort again. Okay, I hope guys you have a good day so far. Dude, don't stress too much, son. Okay, console, boom, boom, we're creating a new one, right? 2021 to run, create, and that's it. Okay, let's go. Okay, what we have to, I have to check again the logic about how actually the quicksort is working, right? So we have to go to YouTube quick, boom, YouTube. I have to open in that up. Blub, blub, bum, bum. Let's go. Quicksort, let's check. Quicksort was from the method that, if I'm reminding correctly, we have two containers, so we're splitting it. So we have two containers, correct? And then we're sorting inside the containers. And after that, we're gonna merge it together, correct? We're gonna check it. We're gonna check it again. Maybe I'm wrong. I don't know. So if you see, no, it was with the pivots. It was with the pivots. Yeah, I got it. I think I got it. So the first thing what we have to do, we have to get our pivot, right? So it was with pivots. That was the quick sort. Wait, did I forget it already? I mean, I think that was this example. Let's see. So you're able to see this quick. It was with the pivots, right? Oh. Okay. The pivot will be in the middle. It was like this. And what will be the pivot again? Selection of the pivot element. The first step in the quicksort algorithm is choosing a pivot element from the array. This can be any element from the array. So we can choose any, right? So it doesn't matter which one we're gonna choose. Interesting. Now I'm remembering. So we have our pivot. So it can be on the left, on the right. So we will have a pivot. And then we're just saying, okay, everything what is bigger than 3, we're going to sort it on the right container. Everything what is smaller than 3, we're going to sort it on the left container. And then we have the recursion. No, we don't have the recursion. It's a recursion because we're calling again the function. So, and then we have more containers, right? And then we... Okay, I got it. And then we have minus 6, minus 3 here. And then we're doing the sorting, right? Where's the sorting point? So we're doing this, minus 6, minus 3. Oh no, we're generating always new pivots? Oh, it's crazy, it's only 1 week ago. I think it's 2. So we have this pivot and then we're generating a new pivot. And then we're doing the sorting again. It was like that. So it's like the pivot sorting. Why it's called the quick sort. It should call the pivot sort, you know? Am I right? Am I wrong? I don't know. Let me know in the comments below. Okay, so quick sort, pivot sort, right? Get in your mind. So then we're choosing always the right thingy here. Then we have our pivot and we're doing the same stuff again. That means we have to program only one time like this function layout, and then the function can call it itself again, right? Itself. It's correct. So minus 3, minus 6, and then we have the 1, right? That's what we're having here. And then we're sorting it again. So, and then we have a new pivot. And then -6, -3. And then we're gonna say, okay, -6 is Interesting. I mean, let's do the first step. Probably I'm gonna programming it this time in another way. Let me check. Let's dive into the focus mode. Let me see. Why you can't hear me? The heck? Should able to hear me now? No. Is it bugged here somewhere? Let me see quick, guys. I'm not able to hear myself. I mean, maybe this is even good. I mean, at least the microphone is working. I don't know why I'm not hearing myself here. Actually, it should work. What the? Can I hear something at least? Let me check quick. Any YouTube video. Watch him.
I'm gonna put the volume where
Wow. Okay, I can hear this. Okay. Why am I not able to? Is it? This is way better. Okay, are you ready? I'm ready. I'm so ready. Let's go and dive into programming. Okay, just first thing what we're gonna do is, again, always, like, we're going to write our print_vec function. So first for that we need, we're doing this everything, we're doing it with vectors. By the way, if you ask yourself, do you know actually what the difference is about the array, like C++ array and vector? Please let me know in the comments below. So we need a vector, correct? So vector, include vector, that's all what we need. And then we don't need a return type, and then, oh, okay, is this maybe better? And then we say print_vec. So this is our thing, and then we have to create even the vector here, quick. Cout, not cout, vec. From type integer. I know, I can do a template if I want to. And we're calling it arrays of numbers. So, okay, it will be what it will be. Let's do 88, 4, 2, 3. This is already sorted. 1, 11. I like this example if you have always like the 11, 6. So, and then we're doing here this 4 maybe. 3. Or we're doing the 5 and then 2001 and 6. So how many do we have? 1, 2, 3, 4, 5, 6, 7, 8. I mean, 8 is okay. So we have that one. Everything is fine. So now we want to print it out. How are we going to do it? Like always, we're going to use the for loop. Auto. If you don't know the auto function, just read it up. Auto element, every element, and we're going to iterate through what? Through the array, and we're going to call later on the array container. So we're just opening it up. So we need here for the print_vec like a input value, and it will be a vector from type integer named container. So then we have to put it in. So we're going to call the function print_vec. Hello, what are you doing? Working on. I'm going again today quick. I'm going quick today for the quick sort. And I just realized that I don't know how to do it again. Because I programmed actually the quick sort only one time, you know? So we're gonna do it with my current level of C++ again. So print_vec. Print_vec. Whack. And we're doing this here. And we're putting in the array of numbers. Perfect, right? So, boom. Yeah, we want to print it, cout. So how are you doing? Always sorting. I'm just getting ready for the exams. Maybe I will sort myself away. Ka-ching. Stood. See out. Element. And that's it. And we're doing that one. Here. Boom. We wanna do some cosmetic things. What do you think about the microphone quality? Is it today better? And we need... What do we need? This here. /n. It should be correct. So, okay, let's see. Let's check if this is actually working. Boom, 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 boom. We're missing here something. Okay. Come on. It's... Oh, okay. Okay. What is the mistake? Why are we printing this even? Mistake. Huge, insane mistake here. Like a misplay, you know? Alright, what I'm doing? What I am doing? Huh? Wait. Wait a second. It's the other way around, right? Ooh. Is it like this? Wait, does it actually make a difference if I'm doing it like that, right? Oh, wait. Both were... No. Both is working? Like I can do it with and without? Dear C++, why is this working? Every day... you don't notice the difference. I just invested like 3 hours today. Okay, good to know. Good to know. There is no difference if I invested like 3 hours today to get like slightly better audio quality. Do you know what's the problem about is if you want to get better, if you want to sound better, right? I mean, you can't get a better voice. No? This is not that easy. What do you think? Is it better to adjust the room or to just get a better microphone? Okay, it depends on the microphone. I mean, if you have this microphone here, it's just like a basic microphone, but it's not like a headset microphone or something. Actually, you have to... What is the answer? What is the answer? Huh? It is the room. Where you're getting the most... what is the name? Where you're getting the most echo? From which direction? From the front direction or from the back direction? No, first room. Sound-wise. Okay. You're getting the most reflection from the back because it's going, everything is going on your front thingies, right? And then it's reflected on the back wall, and then it's going into the microphone. And that's why if you want to reduce this kind of echo effect, you need like on your back some sound reduction panels. And they're not that cheap, right? It depends. So some people doing it in the front, and actually this is completely wrong because the most reflection what you're getting is from the back. Some people have even like a surrounding, but it's also make not that much sense if the most reflection comes from the back, right? Because if you have here this absorbing stuff, right? It's opening in this direction, you're still getting the back noises into the microphone. Yeah, really interesting. Okay, let's keep going. Back to programming. 11, blah, blah, blah. This is everything looking really good. So, first thing what we want to do here is this should be our pivot, right? So this is working. Then we need another voice. We're going to change it later. We're going to call it quick sort, right? And we open it up. Probably the type we know already. We can type already. It will be a vector from type integer. Vector type. Oh, come on. And we're going to call it again container. Here we go. Do you know any C# channel here? Are you really interested to get good in C# programming? Maybe I should ask a friend of mine. He's really good in C#. Maybe he should. Even I would watch his stream, to be honest. Mainly .NET. But yeah, should I try to get him? Like, maybe I should ask him that he's gonna start streaming, because even I would watch his stream. By the way, Microsoft. I mean, that's like, that's the real C# programmer then, right? Okay, let's keep going. If you're okay with game dev, there are a ton of Unity streamers. You mean like game development wise, you can develop games also with C#? Is it really... Is that a good thing? Is it? I don't know. Okay, keep going. So we yeah, it's fine. C# is fine for but C++ is better, right? If you want to get the real performance. Okay, guys, I still don't have an answer why I can do this also. Why is this also correct? I'm gonna hear, why is this here also correct if you're comparing this one with that one? Please let me know why I can do this. Well, the engine where performance is important is in C++, but the implementation is more important than the language. Makes sense. The question was why I can do it with this statement, why it's working with this statement, right? And with that one. Maybe you can explain, I don't know. So we have the output, quick sort, blah, blah, blah. Now we have to get the pivot, right? What will be the pivot? We can call it like integer. We can do it even better, right? Because we're not going to modify the thingies. Actually, yesterday I watched a video about C++ and why not everything is like a constant. It's kind of like a problem. But this you can define as a const and then container, blah, 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 blah. For the next thingy, you can't make a const, but you are able to do the reference. So that means it's valid because it stores a single character. Okay, the other thing would just store a string or what? Would we then store a string? Okay. But why you can do stuff like that? Should be forbidden. Should be forbidden. Why? Because it's C++, huh? Okay, the operator stood O stream operator. Okay. Interesting. Good to know, boys. Okay, keep going. Okay, we need the pivot, right? We're calling it the pivot, right? So how are we gonna define the pivot? The pivot will be... are we going for the quick and dirty solution? Pivot will be the length minus 1, correct? Can we say that? Like, if the size is 7, it will be 6. So minus 2, correct? So what we can do then, we could say pivot is container dot size magic and slash no, not slash, and we're doing minus 2, right? Because we would have the size 7 and that would not work. Oh, what I'm doing here, wait, we need still, wait, big mistake here. We have to do container, boom, and then we have to do this one, right? So minus 2, because if we have minus 1, then we have 6. 6 would be correct. Why minus 2? Make no sense. We need minus 1, right? Minus 1 will be the last element. But maybe we have something for the last element, right? Can I call it somewhere? Size? We can use it with size. Can we not use and with the iterator or something? Probably this is also working, correct? Wait, I want to try it out. Can we not say this? Some problems here. This is not gonna work. Because it's just the iterator. Yeah, it makes sense. It's not gonna work. We have to do it with the size. Okay. So we're going for this method. You can do container back. Oh. Yeah, probably this is better, right? Performance-wise. That we're using that one. Container back. So we're getting last thingy there. So this is fine. And then we can just print it out and test it. See out, and then give me place the pivot. So, okay, we're calling that, blah, blah, should work. We have this here, this is working, but now we want to call it quick sort. Quick sort. And the input will be our array. n/n, boom. So let's see. Oh, our arrow. Okay, let's see what I have. What's the problem? What's the problem? Right, we have the container, okay, and then we say container back will be the pivot, and then we're printing out the pivot. Oh. Beginner mistake. Oh. What? Okay. Wait. Always with this size. What? Why are we getting 2001? You see, this is not gonna work. Okay, guys. Sorry. Okay. Please, no, don't judge me for that. I can do the back thing just like this. Yeah, it makes sense. I don't need like, okay, I got it. Yeah, now we have the 6. So we have our pivot, boys. Okay, first step is done. We have the pivot, right? So if we have the pivot, now we need the statement, then we want to have a right side and left side. It's the same thing what we had before, like we say std, blah, blah, vector, boom, from type integer, and we call it right. And then we say stat. We could say bigger, right? Bigger. If you have a better naming, just let me know. Actually, I like left and right side, but bigger, yeah. I like the left. To be honest, because I'm using it also for my merge sort thingies. So I'm gonna stick to the method, left and right. So then we have it, right? Boom, boom. This we can delete. And now we have to say everything what is what we said, everything what is smaller than the pivot, we want to sort it on the left side, right? That's what we actually want to do. Okay, this means we need the if statement. We could do, last time I did like a for loop, but we could just do everything in recursion, right? So let's go. Let's try it out. So we say if pivot is smaller, if the pivot is smaller than everything, if the pivot is smaller. No, we want to have if pivot is bigger, right? Probably it doesn't matter. Normally you have to do the big numbers on the right. So we're gonna say if the pivot is bigger, then do this, right? Okay, got it. Then left. Container. We have to make a for loop. You have to iterate through that, right? Yeah, then we're just calling it ODX. For now. And then we're gonna define it. Zuck. Yeah, we going for loop here, I guess. So for, and then we say ODX integer, ODX 0, and the statement will be, and we're gonna stop if we have finish at the end, right? Can we say container dot end? Is this possible? Never tried it out. Can we just say ODX is bigger, smaller than, we can say just container size, right? And we are completely fine. And then we're gonna say plus ODX, and then we have it. Okay. Then we're counting that up, and then we're checking, okay, the first element 0, boom, right? That's what we're gonna do, and then we're saying, okay, please, if this is the case, but I mean, we could delete one element, correct? It's -1 actually from the size. Because we always getting like the pivot thing. So it should be -1. Because we not need the last one. And then we can say pivot, bigger container, ODX, and then please do the pushback to the left side. Right? That's what we want to do. So we're going to say left dot pushback, boom, and then we say container, ODX, boom. Right? This is the case. Everything else, this is not the case. We want to have it on the other side. Else, if this is not the case, we want to have the right push back, and then we have container ODX. Correct? Boom. So we had then the left side, the right side. Then we want to have this here first, and then I can use it in my quicksort function. So container back is equal with container size -1. Really, is it? Ah, yeah, -1. Yeah, okay, got it. Yeah, okay. Now we can call this print function check if it's actually working. So print vec, and we're putting in one time the right, and then we're saying print vec, and then we're putting in the left side. So here we go, and then we. So let's check. Everything is gonna break. I mean, I could go through this thingy via debugger to check it, but it should be correct. The size is in this case 1, 2, 3, 4, 5, 6, 7, 8. Right? This container size. So it will be -1. So we have 7. That should be actually correct. Is it? Let me think quick a second. So 1, 2, 0 would be 6. So if it's 7, we would have 6. So we would have 0 6 times. This should be correct. Let me see. Yo, this is looking good. Yo, this is looking good. Am I correct? This is correct, correct? So, yeah. So we have our pivot, we have everything what we need. Now the function can call itself again. Because the container size will change, so we're getting the thingy, and then we can just say, okay, okay. For this, then we need our type. Std vector from type integer. And then we have to say, okay, left will be quicksort. And then one time right. And one time left. Because we need the return part, right? The return value. So, okay. So now we have to merge it, correct? Pivot, right, pushback, print back, blah, 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 left, quicksort, right, quicksort, left. That should work. But we still need... what are we missing, boys? What are we missing? Really, really important. How you can stop the recursion? You need a return, right? Statement. And the return statement will be if the container is 1. So we have to say container size is equal 1. Bam. Do the pushback. The return, sorry. Return of container. We have to do that. Right? Wait. I have to check. Wait a second before you're gonna roast me. Yeah, we can end up in this scenario, correct? Wait, I can't do it this way. Wait, I have to read how the quicksort is working again. Sorry, give me a second, boys. Give me a second. Okay, quicksort. I don't want to read it like for C++. Where is it? Here, okay. So we have the 11, and then we're doing it again. So we have 7, 4, 12, blah, 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 and then we're doing the pushback. And if you have the pushback, so how are we gonna merge it? So let me see. Something else. Am I why I have a problem right now? It should be super easy for me. Let me see that. Okay, I think this graphic is way better. Way better. Let's check. Okay, we have that one. Okay. Fixed sort. Pivot 4. What? Okay. Focus. Yeah, okay, we did this. Okay, fine. Vents on its right are bigger, so no swap. Oh wait, I'm doing it wrong. We're swapping it. We're not creating new vectors and stuff like that. We not have to do this. It's not like a merge sort or something. I'm just trying to... boys! I'm sorry. I'm sorry. I'm literally sorry. Okay, here, boom, back. That statement could be... I mean, okay. My mistake. I mean, I could create a new one if I want to. How I did it last time. So this is the all elements on the left are smaller, all elements on the right are... Okay, we're sorting it like that then, okay. No, I think I'm still correct. Let me think. I have different more than one solution for the problem. Aha, interesting. So the question is what I have. Am I going for the... We not have to create a new array for this. Can just swap it if we know the position from... Because the 4 will be always the middle, right? Kinda. So we can use the solution what I had back then, like with the merge sort. How big the container size will be. To figure out what will be the middle. Because then if we know what is the middle, we know actually what will be the what numbers we have to swap. Oh, I think I will go for this method. I really like this. This is interesting. Is it then even recursion? Yeah, it's because we're gonna recall it again. Assistant. So then we have that. Okay. Swap, 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 swap. And then we have the 4. But is this then even a quicksort then? Right, I have to check. It's crazy, right? That's why you have to redo stuff. Practice, 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 practice. So we have that one. Then the pivot will be, for example, I don't know, the 1, right? These drawings are always that terrible, man, to be honest. I mean, I still have my quicksort solution, but maybe I'm looking for other implementation this time. So 30. Then we have to pivot 13. Correct. And then we're going to sort 11, 4, 12, 7. So I got this. And then we're going to split this up again. And that's what we're actually also doing. So we're getting a new pivot. We're getting a new pivot. The end of the thingy. Because we will have then 7, 12, 4. So we have... wait a second. Why we have the 11s though? Ah, because it's this block. Okay. Thirteen is the pivot. Then 11 will be the pivot. Okay, got it. And then we have this 7, 4. So the 4 will be the pivot. So why... okay. Yeah, we are on the right track, boys. So if the container size will be only 2, then the 4 will be the pivot. And if the pivot 4 will be smaller than 7, so it will be get pushed on the 7. So okay, wish you a nice day, man. Then we're pushing it on the 4. And then we can just return it. And then we're returning the 7, and then it's sorted kind of, right? Then we keep pushing back. Then we have the 4, 7, 11, 12. 15, 16, 18, 19. Yeah. Yeah, I still need I mean, this is working already. Gonna end up with that one. We have to push back also the pivot. That's the thing. And we have the equal scenario. So we have to push back the... yeah. Okay, we need right, left, and equal. We can do the equal sometimes. You know, we can edit later. But we have to push back the pivot. Do we? If the pivot... Why? I'm just wondering why I have so much problems right now. I mean, hello. Okay, let me see. So we have 7, 4, then we have 4, 7. Of course, 4, 7. There's not even a 7 in though. What is this example? Why we not have here 7? What is this example again? How we can have here 7? Am I blind? Oh, this is so... No, there's no 7, but yeah, now we have here 7. Okay, I want to have another example. I don't like it. Quicksort. No. So... Nope. Pivot element 7, okay. Then we have 6, 1, 3. So then we're doing the same thing again. And we have this both, and then the pivot will be this 3. Yeah, I'm just gonna read. I'm a little bit confused right now. 3, then we have 6, 1. Yeah, it's okay yet. That will be the pivot, and we have 6, 1. 3 is smaller than 1. Yeah, then we're ending up like with that one. Okay. And then we're gonna merge it. Ah. So if the container size left is one size and the right is the one size, right? Could we end up to... I mean, this is like, if we have one element, we're gonna push it back. That's what we're gonna do. If we have one element, we're gonna push back. But we have to push back also like we have to push back also the pivot. Warum? So if this here is the pivot and we're sorting like this side, okay, what is, then we have one container here and one container here. That makes absolutely sense. So this will be on the left, this will be on the right. Correct. And then we have the pivot. So we have to merge these thingies together. Create a new vector, merge this thingy together, and push it back. Right? So we have this scenario, we're gonna do this, push back. So we have right side, left side. And if then now we need the other cases even. Okay. I think I got it. So let me try. So that means the if statement, if left side equal 1. Now first we need then to create We have that. So we have one element. We not have to push it back like this. We have to create. But then we're always creating one, right? Could create inside. That makes no sense. Just gonna do it for now. How I'm gonna call it? Merge? Fuck it. No better naming for it. So then we're gonna say, okay. Could do the pushback here then, right? True. If now we need a okay, if left side equal 1, do this. Huh? Okay. Huh? Okay. So if right.size equal 1. So what will be first one? Now we need if. We don't have to do it with the pivot. We can do it just here then, because then we can say, for example, the pivot have to be in the middle. So we can do it with the left side and then the pivot in the middle. Yeah. Then we don't saying pushback. For this, that has to be first. And then we can say pushback. So, okay. So we have it like for the left side, we want to push it back. And then we need like also the pushback, the pivot, what I have to push back. But this is like always if it's the size. So we need also the right size in it. I mean, you could just do a statement with like, this is bullshit what I'm doing right now. Because I can just say, okay, if we have this and this. And then we're doing merge this here and then left and pivot. Then we could have it also inside there. And we're going to return it. And then we're going to push this back. Then we have 2 blocks. This is not going to work. So if you have the recursion stuff, then we're going to have 2 blocks. For example, with the new numbers, right? And we have to merge this also again together. So I need a rule. So if I have the 2 blocks, I have to merge them also again together. How I'm going to do this? I have the 2 blocks and I want to merge them together. So each block have a size. The one have a size, the second one have a size. So I want to create a new... I'm going to push back both just then, right? But what is then the logic behind it? So let me draw quick. So we have then 2 blocks. We're returning 2 blocks. Each block has a size, like size, and we have to merge them also again together. So I need a statement for doing that. But how I know this is already sorted? What is here wrong? This is also wrong if I have 1 container. Wait, I can do it way better. I can keep doing it until... I'm a little bit confused because everyone is describing it a little bit differently, like this quick sorts thingy. But I could always end up with the pivot, right? Can I I could say, okay, I have a block of 2. Let me think quick. So if you have this, and the 6 will be my pivot, for example. And I have my 7. 6 is smaller than 7. So it will go to the right thingy. I'm not even checking it anymore. Because I have -1 in my statement. So we know that 7 will go to the right. That's what we know. So 7 will go to the right because it's bigger. And then we have our pivot. And this here will be nothing, right? Because we have already our pivot. We're not pushing in the pivot into this thingies here. Not doing this. So we have to push back then first the pivot. Oh, man, ey. Ah. So why is this not working? Here we're getting 2 blocks back. This is why it's not working. Let me think. I want to solve it quick. So I think this logic is okay. But do we have a good documentation about the quicksort? I mean, everyone is drawing it like differently. Maybe Wikipedia or whatever. Too bad. Sorry. You know, everyone is drawing it differently. I'm not getting it. Here also again. So we have 3. The 1 is the pivot, and then we have that one. So this will also get pushed back. So we have here again right and left side. Okay, maybe someone of you guys can explain why I am confused. Try and rearrange the array. That is the gut part. The other part is recursive. But, do you know why? What I'm not understanding what's up? Did I have trouble right now with that? Did I still have problems sometimes to visualize? And I'm understanding now the technique, but it's like I'm not understanding the concept. Because even like if you have the sources here, they're doing it differently. Sometimes they're sorting it already. What is the definition of quicksort? I want to have a correct definition for the quicksort. It's like everyone is drawing it slightly differently. I need just a good source. So similar to the merge sort algorithm, the quicksort algorithm is a divided and conquer algorithm. It initializes. Okay, I'm gonna check. But this source was so many times incorrect. No, it's not something like this. It's like the implementation is a little bit slightly different, and I want to have the exact definition for the quicksort. I mean, for the merge sort, you have like. You don't have definition based on implementation, so then it doesn't matter how you're gonna do it or what. They're doing it even differently here. Now I'm super confused. I mean, there has to be like a definition for it, or am I wrong? Here, even they're sorting it before. You're not seeing that. I'm literally getting a little bit triggered here at the moment. Let me show you here. Here, they're even sorting it before. Oh no, this is a pivot here. Unsorted array. Okay, you have the pivot and you have high, low. Okay, I'm not getting the idea. I'm not understanding the idea from Quicksort. I thought I understood it. Okay. It's not like the programming thing. It's like more the understanding thing here right now. It's okay, I'm gonna draw. So let's do the example. Still don't know what the definition is then, how, you know, if it's not a fixed definition. If you have, for example, 11, 6, 14, 15. Then 15 will be the pivot. Then we would have 15. Then we will have 11. And 6. 11. No, wait, this is wrong. Ah, this is also a bad example here. So 10 will be the pivot. 10. Then we have the bigger ones on this side. 11, 14. Then we would have here the smallest, 8. So we have here right side, here we have the left side, and here this is our pivot. Yeah? So this is the first state what we would have. Next state will be we're gonna recall the function again. That means we put this here then into the function again, so it will be 8, and 8 will be the pivot then. And we would return the pivot later on. And then we would merge these two together. Eight plus 10. Here the same. This would go deeper. Then 14 would be the pivot. And then we would have here then one time returning 11 and one time returning 14. Right. But why are you doing this? Then you can do a merge sort again. This is so weird. You're doing the implementation is just an. Okay. So then you're just returning it. Then this will be the new right side because you're just returning it. That will be the right side. Then you have the pivot. then you say just, okay, you have a new, you're just merging it together then. You're just saying R plus P plus left side, and then you have it. But the problem is then this will become the pivot. But this is not a problem. Because you're returning it then, if you have this case. Then you just have to merge it together, and then you're getting like 8, 10, 11, 14. You can't jump the gun now. What do you mean? So I mean, I have already everything. If left side is 1, this right side is 1. Then we're doing this merge. Then we say this and this and this and this. The problem, this is not working like that, right? If the number will be bigger, this is not gonna work. Because left side can be bigger. We have to do it after this here. This is finished. Yeah, okay. I think I know how to do it now. What kind of, you said the implementation is not important. And if I'm using this implementation, you're saying it's not a quicksort or what? And you said like there is no definition like for the implementation. I mean, I can just do the same method what I did with the merge sort, correct? I can just merge them now together. Because there is, you said like no rule for the implementation. Or am I wrong? I can do it with the iterators again. I guess you should try. Okay, I'm gonna try. So we have that one, and then we're gonna say, okay, what he said, we need then iterator left, and that will be left begin, and then we say iterator right, that will be right dot begin, and then we need auto, of course. Auto. So, and then let's see, if you have it like this, then we can say we have to merge it together. For this merge together, we need also vector type integer merge. That's it. And then we need this is a merge sort. Man. It's not by definition merge sort because I have pivots. I'm doing it literally with the pivots. Yeah, but you're probably you're right, man. What is okay? Okay, I have to watch a YouTube video. I don't know. Let's continue. But it's maybe you're correct. Maybe it's a merge sort then. I don't know. Oh no, this was not like this one. What was it? Remember, so we have to the if statement. If this value, wait, we need no. What I'm doing, this is completely wrong. So if this is bigger, no, we not have to do it like this. We just have to read it in then. I could do it completely differently. Right. What we could do it 4, and then we're gonna say oh man, coffee is not good sometimes. So then we have to do it for the right. Why it's changing it up always? What the heck? Ey, Mann, jetzt krieg ich die Krätze, Alter. Ohne Mist. Left, right. Actually, we need the pivot first. Hey, how you doing, man? What will be the result? That will be funny. Okay. Okay. Why is this not working? Ah, okay. Okay, still not a problem. Oh, I know why. I know why. Do we have the... This is wrong, we don't need this anymore, right? 1 second. Okay. What is wrong? Let's see. So our container will be 3 then, right? 11,600. What is like the thingy? Let me check quick. What the number? Okay, this is correct. We're going deep in. Boom, boom, boom. You should check size before using back. Yay! Back on the MTS UB. You mean this here? How we can have an empty vector? You mean if we have only one variable in and we say container back, we're not getting the one variable or what? Let's see, we're just going through that and I should see it then. You don't know. Okay, container size is 0 this time. Ha 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 ha. Why it's 0? Oh, wait. Aha. Okay, wait. I want to go into this scenario again. This was really interesting. Let's do it. Yeah. I mean, you can learn something in debugging, right? So let's go there. So container is 3. Okay. This is working. So we have pivot is 2001. Right and left is nothing then, right? Mm-hmm. We have still 3 elements in the container. Wait. Why we have 2001 in the container if the pivot is... Yeah, this is correct. Okay. And we push back the 11 and the... Okay, let me see. Let me see. So we have on the right, left side, now the 11. Huh? We have 3 elements? We have 3 elements. Why are we not pushing back the 688? Ah, okay, I see. I know why. I know why. This is not gonna work. I have to do an if. Actually, we need something for equal also. Okay, let's go into this again. Okay, next time. So container size will be 3. Same scenario. Pivot, blah, 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 blah. And no, left side will be 11. Pivot is smaller. What? Why are we overjumping this? Who's laughing now? Oh, yeah, you're laughing, right? Dude. The problem is if you're comparing like the Quicksort with the Merge Sword, everyone is doing it slightly different. I mean, from the logic, you know what I mean? That's why I'm confused. So now we have this one. This is wrong. No, this is correct. Oh no, this is not working like this. Oh man, oh was für ein Fehler, what a mistake. Because the index will be then just bigger. I mean, the index is correct. I mean, no, it is correct. Okay, no mistake. Look at 26 to 36. Okay, we're putting something on the right side, right? No. Why are we putting in an empty... I'm not getting the mistake, boys. Hey, Edward. Oh, man, hey. Yesterday was such a nice day. And today it's like... I just told you why it's empty. Why it's empty. Okay, I'm gonna read everything what you just wrote here. Cause out of bound. No. I mean, we have this if the container size is equal 1. Then we just instantly returning it. So it's finished. Why we can even be inside this thingy if we have this statement before. Why we can have 0 container as an empty vector. How is this even possible? Do you know what I thought? That I just come on today, just writing the Quicksort in 20 minutes and that's it. So now we are already in 1 hour and 30 minutes. Nice! Okay, I have to concentrate. The problem is, maybe I have a problem that I'm tilting too fast and then I'm not thinking anymore. You know what I mean? Because like the anger, like I'm getting more and more angry. Instead of just staying calm. But it's building up inside my body. If that makes sense. It's just building up, you know? Okay. We're going through, we're gonna debug again. Okay, I'm gonna do it again. Okay. Step by step. No, don't rush it. So we're going to zoom a little bit more out. Okay, we have here my variables and we're going step by step. Okay, so we're going here in blah, 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 blah. So the container size is 8, right? 7. Oh, wait a second. The container size is 8. Oh yeah, it is 8. It makes sense. Okay, everything's fine. Okay. Keep going. What if the container is 0? We should be not inside there if the container is 0. Because we... If the container size is equal 1, then we're gonna return it. How it should be 0? What is the scenario that we're ending up to putting into this thingy a vector from the size 0? Like an empty vector. How we can end up that? In that, you know, because if we're gonna return it, we have 1, and then we say quick sort. And it will still have a size of 1. Did you understand my point? What happened if you have 2 elements in the vector? If I have 2 elements in the vector, one will be the pivot. Oh, the right or left could be empty. What is this money now? So if right is empty, but we're not gonna return it then. We have right now only the scenario that we're going to return something if the container is 1. So if the value would be 1 and we're going inside in our function, the container will be 1, and then we instantly would return it again. Finished, return, container. I'm not understanding it. Maybe someone have in Discord time to explain my problem here. Nah. Okay, we're going through this step again, step by step. I'm trying not to get angry here. Okay, let's go. So we have the pivot here is 6. This is correct. I will go step by step now. Trying to stay calm. So we have pivot is smaller than 6. And we're doing it for everything. So now we what is the index? 0, right? Let's check. 0 is the 11. So 0 is not smaller. The pivot is smaller than this container, so we should go into that one, right? Yeah, okay. So we're pushing it back. Okay, correct. So we keep doing this stuff. Okay. Okay. So the left side has already 2, 1, 4. The ODX is 4. Now ODX is 5. Then we are on this position. And we should use this then, yeah. And this is the last rotation. So ODX is then 5, now 6. And 6 would be the 2001. And it should be on the right side then. Okay, everything correct. So far. Oh. 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 I think I get my point. I get. Oh, no. Oh, let me see. I think I can. So. What? Why are we going another time in? No, we're not going. So we have the quick sort. Now we have the right thingies, right? So the right side will be the 11, 288 and 2001. 2001 will be the new pivot. So we're going into that one. So we have a new pivot. And we're going into that one. So that means 2001. So the container 11 is smaller, so it will be on the left side. Actually, everything will be on the left side. Everything will be on the left side. Yeah. We're doing it another time. Huh? So we're in the second rotation. ODX is 1. Container. Yeah, that's correct. That's correct. Okay. Finished. So now we have the left side. We have 2 of them. So we're going into that one then. Step into this. So 688 will be the pivot. How can be the container 0? Oh mein Gott. Oh nein, was habe ich denn hier gemacht? Och Leute, ey, keiner hat mir geholfen. Ohne Scheiß, ey. Ey, ihr seid... Oh mein... Ey... Oh Mann, ey, das ist so funny, hä? Oh ja, super funny, aha. Still the same problem or what? Okay, we debugged already something. Okay, let's go to the same scenario again. So, container is 4. Let's keep going. So, container size is 3. Not another time we have to do it. So, container size is 3. Now we have 2. We have 2 and 1. So we have only one element then on the right side. And it's the 2, so we're going into that one. Okay, it seems like I'm understanding something. I'm not understanding it. So how it can be, if I'm putting something in with a size of 1, then if we inside this function again, it will have a size of 0. What am I missing? Maybe I'm missing like a fundamental understanding why the container. I mean, if we're doing this call with left, correct? I thought first we're doing the left side and then we're doing the right side, and we're right now on the left side. So we're putting something in with a size of 1. How it can be if we're using the debugger, then 1 is 0. So container size is 1, 2, 3. Then left is 1, 2. Right is empty. Have you tried printing left, right before you do a recursion? I think there is a fundamental. So, okay. If I'm doing recursive call, first we're doing this one, right? It's not like in the same time, right? First we're doing the left. Until this is finished, we're doing the right. Am I right? Am I wrong? But if we have this method and we're doing this recursive like thingy here, and I'm pretty sure that I'm understanding something. I'm missing some information. Why I have so many problems right now. I have one problem, guys. What I'm not understanding. So if I'm doing this step here with this container, ODX, and whatever, I have only one return state. Why it's getting called another time? Oh, man! Why it's am I'm Okay, so if the container size is dot equals 0, it's meaningless in this algorithm. No, the problem is I'm missing some. The problem is how I can return even something if I'm not have a return. How is this? We should stay like forever in this loop, right? How I'm missing a concept. Oh no. Wait. Yeah, why I'm calling? Because we got coming here, right? And then I'm calling it again, and the container is. Oh man, A9. So this finished, so we're gonna call it again, right? Mm-hmm. Mm-hmm. So right and left changed. Ah. So if right and left change and I call it again, and I say container.back, but the container will be the left. I'm still not understanding it, why it can be 0. Does someone have time in Discord maybe to explain me the thingy? Would be really, really nice. Do you understand my point here? Okay, I'm gonna read them chat messages. In this algorithm, container can suddenly go to 0. But in this case, what I have at the moment, how it can be 0. Oh. Oh man, ich bin ja. Okay, I got it. I know why it can be 0. Okay, I got it. Sorry, boys. Ja, natürlich kann 0 sein. Should we do it like, oh man, what? Sorry guys, I'm really sorry. So of course it can be 0. I got it. Thanks a lot, guys. So what I have to do then? So I need the if statement that I'm gonna say if the. So this is then the problem. If we need here the if statement. If container size. Okay, how I'm gonna do it? Like if container. No, what we have to do actually is we just going into this one. If container size is 1, then we're doing that one. Otherwise, we're not gonna do it. Correct? Oh no, sorry. If container size is, should we say equal 1? Bigger than 1? bigger, equal 1. Equal 1. Something like this. Or is this not working? That should now solve the problem. Left can be still. I have to do it a little bit differently, right? I have to say if left side, just do it like this. I mean, this is not a quick and dirty Worked, finished. It's working. Is this now a quicksort or not? The question, is it a merge sort or is it a quick sort? Yeah, I know we need equal. And not have the equal scenario at the moment. Remember what I said about comparing two integers, that outcome is... I mean, this is correct, right? Isn't it? I need two if statements, correct? I can't do it with if else. I think also my merge sort I have no equal thingy. Line 29. What is this? Ah, you mean this one? Ah, sorry. What I can do is then I can say else. Oh, wait. And then we have also the equal case, right? Let's test. Worked, right? So my question is now, is this now by definition a quick sort? If you're gonna say no, no. Is this here the quicksort, boys? By definition. I tried it. You can see it, right? Oh, you're not seeing the result? 1 second, my mistake. Let me see. Give me a second. If you come, blah, 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 blah. Yeah. Say hello. I'm gonna show you the result. Nach was sieht das aus, mein Schnucki? Spielen. This is a game. I'm playing games, you know. Because you know what funny is? If I'm programming, my girlfriend's just thinking always that I'm playing games. So, display capture. Nee. Oben gibt's noch das Dingens, ne? Meine Mutter hat ja was gemacht. I guess this is a quicksort. It is. Oh, perfect. I mean, it's not like a really good one, right? I know. Why is Windows capturing not working? Here. Chrome. I'm not getting there. I know why. So you can see it's working. Give me a second. Here you can see the result. Are you happy now? Okay, I know. Do you know what my problem actually was? And I have a question for you guys. How I can prevent that I'm stuck in a wrong layer if I'm going through a code, if I have recursion? Are you getting my point? Because the mistake what I did, that I thought segfault, yep. Are you getting my point? That I had the problem that I thought that I'm returning already something. I don't know why. And then I was kind of blinded, you know. I don't know how to say it. I thought always, if I'm doing this here, the left thingy will be always 1. And that was not correct. It can be 0. And then I will putting in a 0 element here. So this is a quicksort, correct? Infinity recursion leads to segfault in C++ since you will go out of the bounds on the stack. Okay. But is it normal that you can be like that stuck? I mean, it was not a difficult topic. And I got even angry that I was not able to solve it. Furthermore, I think it was really hard to watch for you guys. I'm really sorry for this. On paper. No, I had like the problem that I was already one step ahead, you know, with this recursion thing. So actually, I was like, even if I used the debug, I was already one step ahead. And then I completely missed the scenario if I have this scenario left can be 0. Right? And then I'm putting here into this quicksort thingy a 0. And if I have a 0, this is not going to work if I'm doing the container .back. I thought you asked about what happens with infinitive recursion. But it's good that you said it to me. I know that you have like the stack thingy, so you will have one time like probably Stack Overflow or something, right? The debugger doesn't show you the whole picture right down on paper, does. So it's better to use a paper if I'm doing stuff like this. So if I'm for example doing my exams, it's better to have like a paper on my other side or something. I mean, if something like this is happening in an exam, you're right. I was completely just I was stuck, and it was like it was like I had no problems to program it. It was like a logic problem. And it's even more worse, right? If something like this is going to happen. But is this by definition a quicksort? You see how every side that show this algorithm brought down diagram and values for each step? But how I missed this? That left can be 0. I not even after I know it now. It makes absolutely sense because it could be the scenario that but I think you're correct. I think it's really good if you have something like this. Just write in the beginning down the logic, right? So if you have the pivot, what kind of scenarios you can have? So you can have the scenario, for example, that the left side is empty or the right side is empty, right? I think it's really, I think it makes absolutely sense to use a paper for that. Just write down which kind of logics you have to implement. So you have to ask yourself, okay, if you have this algorithm or something like this, what kind of scenarios you will have? And then you can code it. Because I just missed the scenarios that the left side can be 0. Because I will there is a scenario that I will have no element on the left side. You made the wrong assumption. You thought if container size yeah, you're right. You made the wrong assumption. You thought if the container size dot size is bigger than yeah, exactly. Exactly. And do you know why I had like a problem with that? I thought already I'm in the recursion, that I'm returning already something. And that's why I not understood why left can be 0. You got this point? So I was already one step ahead, and then I thought, okay, if I'm returning something with a value, how it can be actually 0. So next stream, I will have a paper here, right? And then I would just write down the logic, which kind of edge cases or whatever I have to define a logic for these edge cases or whatever. Step by step. I think it's, yeah. And this is like even a simple implementation, and I failed it so hard. If that makes sense. So is this by definition, you said this is by definition quicksort. So you can say, okay, this isn't a quicksort or what? Can you implement it like that? Do you know what would be now more interesting? To check out my last quicksort, right? We can save it, and then we're checking out my old code. I think I have it even in my Discord. So let me check. I mean, my implementation is really slow, but it should be enough. Okay, let's check my old implementation, my last one, right? But to be honest, for my exams, that should be enough, right? Let me check. Merge sort. Oh, not even posted it. Okay. Okay, then I have to restart quick Visual Studio. Give me a second, boys. Where are you from? I'm from Germany. I know my English is so good that just kidding. Let me check Visual Studio. So, but are you a professional programmer, by the way? Are you? Oh no, why I'm opening the same project again? What was my... I'm learning. So you're learning C++? Maybe I should start to make a proper project one this week. Today, console. What was my last project? 13? No, it was not 13. Merge sort, it was here. Then the day before. Yeah. Oh no, this is also merge sort. Holy shit. Okay, this is the merge sort. Okay. Give me a second. Give me a second. I have to find my merge sort. Today, this week, merge sort application 15. Is it 14, maybe 12? Yeah, maybe 13. Let me check quick. Oh, yeah. Okay, let me check. Here we go. What? Why you have this Windows capture? Why you have browser? Something is broken, for sure. Here. So that was my last implementation. You should start DSA course. What is a DSA course, guys? DSA. Regulated online and platforms such as marketplace, social network, content sharing platforms, app stores, blah, 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 blah. And programming. Data structure or what? Oh. Yeah, I should start with this stuff. Data structure and algorithm. Yeah, first I have to complete my exams and then probably I'm gonna do stuff like this. In C++. Let's check my code. What I did here differently. So, okay, we did like this equal. We have this quick sort. It's actually the same first pivot. We just worked with pivots. Then we say if the container size is bigger than 1. Oh. Then we not have the problem here, right? And then we say pivot is equal container dot back. And then we say equals dot pushback pivot. So we're going to push back the pivot. That makes sense. Does it? For the equals, yeah, that makes sense. And then we have later on the left side smaller plus equals plus bigger. Okay. This is way better for the readability, right? So then we have our for loop here, and then we have our statements. And then we have container size -1. And then we have... Oh, this is the size then. Okay, -1. This is even more efficient here, right? Can you do it without the use of vectors? Probably I can. With a little bit more of trouble. This one won't get you past example. What do you mean with example? It's too weird and slow. No one care about merge sort. I thought merge sort is better. Exams. You mean exams? I mean, I think, why not? By definition, it is I mean, to be honest, boy. To be honest, I could just use, you know what? I can just use something like include, and then I could use, what is it? Algorithm, right? Was it that one? And then I could use even like merge, babam. Yeah? It would be way more efficient. Do it for me. I have to check my time, actually. I have to check my mobile time because I promised some people today to... Oh, okay. I have more time to stream. Okay, then we can have more time today with programming. This is really nice. Then we can do it without vectors or something, right? So let me check here. So we have the pivot, and then we have like it's shrinking down. I mean, this is more efficient, right? Then we have smaller quick sort, smaller, bigger, quick sort, bigger. Actually, the same scenario here. And wait, how big is this statement? Where it's gonna end? Ah, okay. This is okay. This is cool. Yeah, that makes sense. And then we're just gonna push back element, and then we return smaller. Yeah, you can do it also like this. Yeah, that makes sense. Yeah. And then we're gonna return the Why we need here to return the container if we have here return smaller? Is it for the scenario? Ooh, can someone explain? I mean, you can just use debugger quick. Can you actually do a step backwards with the debugger? Is this possible? But I'm not understanding why we have in the end the container if we have returned smaller, right? It is the base case? What does the base case means? It's triggered if container size is smaller than 1. Ah, okay. No, we have it the other way around. If a container size is bigger than 1. Ah. Smaller than 1. But then we would return nothing, correct? How we could end up that we would have a size of 0 again. If the container size is smaller equal 1, then we're gonna return it. And then we would have it like where? Here, then we would just have here a 0. We have here return. Am I again like in the wrong layer? I mean, the function can call itself several times. And we could have a scenario where it's 0. And if it's 0, we're just gonna returning the 0. So it's just gonna stop then. It's finished. But why I have to return the 0? Because it has to stop then. Otherwise I would be like in an infinity loop, right? It's keep looping, and then I need a return. Is this the reason? Oh, sorry, it's like the... Is it just to... So if I not have that, I could end up in an infinity loop, right? Let's try it out. What is gonna happen if I have this? Yeah. key. Yeah. That's why I need it. So if the last element is 0. So I'm returning, okay. 1, 5, okay. So how I can end up to have 0 if I have only one element? It's the same scenario than before. This could be 0 then. That's the same scenario. Could be 0. It's calling it again. So we would have 0. And to stop this infinity loop, we need this return container. I guess I was wrong to call it this quicksort. The idea is similar to quicksort, but you use more space than a typical quicksort implementation. What do you mean? Now you're saying, I asked you before, is there a definition for the implementation? Yet you say, okay, this is not a quicksort because I'm using more space than a typical quicksort implementation. And I asked you before, what is a typical quicksort implementation? And you said there are like several implementations. I mean, I think this catches the point of quicksorts well enough for most. Okay. And to be honest, if you have 2 semesters, right, and someone is asking you to write a quicksort and you're writing something like this, then it should be enough. Even if he's just deleting you 2 points or whatever. I mean, in my point of view, it makes actually no sense to learn C++ if you have like only, 14 weeks, every week 2 hours of C++, and this 2 semesters. And then learning object-oriented programming. So this is in total, let's calculate, right? You have like 14 weeks, every week 2 hours. Then you have ending up like 28 hours in total. That'll be like 30 per semester. So you have like 60 hours in C++. This is nothing. In my point of view, 60 hours is not enough to understand how object-oriented programming is actually working. Or am I wrong? So, but we can go today. If I have more time, we can go today for more better solutions. Because I know the recursion solutions are not the best ones. Okay, what I should do next? Edward, are you still here? Okay. Probably I will make a quick break and then I'm gonna watch a video about Quicksort and see how other people implementing Quicksort, and then yeah. What do you think about this? Should we do it? I think yes. Let's go YouTube. And we are going to where we are going. Quicksort. C++. In 30 minutes. Let's watch this. YouTube. Quicksort.
Hey, it's your bro. Hope you're doing well. And in this video, I'm going to explain the quicksort algorithm in computer science. Yep. So sit back, relax, and enjoy the show. Alright, quicksort. Here's how quicksort is going to work. We need an array or some other type of collection. I have a simple unordered array. What we do is that we'll pass our array as an argument into a quicksort function. After passing our array as an argument to the quicksort function, we need to pick a pivot. There's different variations of quicksort. We can either pick a pivot at the beginning, the middle, or at the end. But with most standard quicksort algorithms, we will set the pivot to be at the end of our array. What we're trying to accomplish is that we need to find the final resting place of our pivot. Where is this value going to be? And taking a look at this, that would be right about here. But we don't know that yet. So to find the final resting place of this value, our pivot, here's what we can do. We will declare and use two indices, j and I. J will begin at the start of our array. I will be one less than the beginning of our array, and that's going to be important later. And we'll need the help of a temporary variable so we can swap some values. All we're doing is checking to see if the value at j is less than our pivot. If it's greater than our pivot or equal to our pivot, we ignore it. 8 is greater than 5, we ignore this value, and then increment j by 1.
Okay, that makes sense. So we're going 1 times through the thingy here. Correct. So we just let the bigger numbers on the left side, and then we're just changing the stuff. Actually, what is... actually, you can sort only one side. There's a big O-time complexity, how well it scale. But there's also space requirement. If you say your quicksort implementation use 2 multiplies n space instead of n, then some people might not consider it quicksort. I'm not computer science, so you could be wrong about how scientists define quicksort. Yeah, that's kind of the problem. I think merge sort is way better defined, correct? I mean, I think everything, how it called n high something, right? If it's something like multiplies, 2 multiplies with something, it's not like an issue. But if you have something instead of n high 3, for example, you would end up with n high 4. I think they would not accept something like this. But if you're adding like an overhead, if the principle is correct, I think it will be not a problem.
So during that last iteration, I did not come into play yet, but it will this round. Again, we check to see if this value is less than our pivot, which it is. What we do now is increment I. Then what comes next is that we swap these two values, I and j. And
yeah, but if you're reading these definitions, the implementation is completely different, right? Because first you have this implementation. Okay, you have a pivot, and then you're doing this and this and this. If you're just looking at the diagrams,
we'll need the help of a temporary variable. So take the value at I, assign it to temp. Take the value at j, assign it to I. Take the value within temp, assign it to j. Then we can move on to the next.
Is this a quicksort?
Iteration. Increment j. We check to see if the value at j is less than our pivot.
And it is. Yeah.
If that is the case, we increment I. swap these two values. We'll repeat this process until J reaches our pivot. Then we can move on to the next step.
Of course, this is way faster, right? Wait, is this not more like...
Here's the next step after our index J reaches our pivot. We now know where the final resting place of our pivot is going to be. It's I incremented by 1. So we will increment I, then swap the value at index of I with the value at our pivot. Our pivot is now within the correct place. An easy way to tell is that all elements to the left of our pivot should be less than our pivot, but they're not necessarily going to be in order, and that's fine. They'll be less than with the value at our pivot. Then swap the value at index of I with the value at our pivot. Resting after. Here's the next step after our index J reaches our pivot. We now know where the final resting place of our pivot is going to be. It's I incremented by 1. So we will increment I, then swap the value at index of I with the value at our pivot. Our pivot is now within the correct place. An easy way to tell is that all elements to the left of our pivot should be less than our pivot, but they're not necessarily going to be in order, and that's fine. They'll be organized later. All elements to the right of our pivot should be greater than or equal to our pivot. And like I said before, they probably will not be in order. The important...
Why don't you try implement the things they do? It was more performance efficient. You will see the idea is the same. Yeah, the idea is the same, but you know, if you're just checking the diagrams, it's not the same because you kind of sorting already before, you know what I mean? You're not creating containers or something, but I get the point. But still, I'm missing the definition, like, of quicksort.
The thing is that elements to the left should be less than our pivot. Elements to the right should be greater than. That's how we know the pivot's in the correct place. Now the next step, we're going to create 2 sections, 2 partitions. The first...
So you can just say, so the definition for the quicksort is you have a pivot and you want to end up that the pivot will be in the middle, kinda, right? And you have on the one side the higher numbers, on the other side from the right side you want to have the highest numbers, on the left side you want to not higher, bigger numbers on the right side. On the left side, you want to have the lower numbers, right? You want to end up like this in this scenario. And it doesn't matter how you're going to implement it, right? There's some ways they are more efficient. In my way, for example, it's not that efficient. So, can you say it like that? You didn't have like a basic rule, and the basic rule will be that 8 is my pivot, for example, in this example, and then you will end up to have the lower numbers on the left side and the bigger numbers on the right side, or smaller numbers, right, on the left side.
Will be all the elements from the beginning of our array up until our pivot, but not including the pivot. And our second partition will be all the elements after our pivot until the end of our array. Quicksort is a recursive algorithm. We need to pass these partitions as arguments into the quicksort function. Remember that the quicksort algorithm...
Yeah, then we can, if you have that one, so this one is faster what I did. Okay, interesting. Why is mine slower? Let me open my version quick again. They do a kind of things without using vector extra space. That is a yeah, okay, makes sense. But could we not use like something like std move or something to speed it up even? We could, right?
Algorithm is a recursive divide and conquer algorithm. But unlike with merge sort, we create new subarrays. With quicksort, we will be sorting these arrays in place, but we need to keep track of the...
This is the definition. We're sorting it in place. So if this is the definition, I not program the quicksort. Correct? Because you're sorting the stuff in place, and I'm not doing it.
The beginning and ending indices of these partitions.
Since you use weird things, push left, push right, you need to extra space, then you need to merge, which is pretty unnecessary.
And then it's just a matter of repeating the same steps over again, but we're going to instead use these partitions.
But you heard the definition. The definition is that you're sorting in place, right? That's what actually you are doing. But I'm doing it also, right? Am I?
Partitions, sections of our array. I'll give you a quick demonstration of what the quicksort algorithm is going to look like to completion.
You also did not pre-allocate left and right vectors. Okay, then you have the quicksort and how you're gonna merge it then. So you if you have two, so you have to check if this is sorted or what, or how you're gonna do it. I have to see like a proper implementation, to be honest, because if you have the 1 and the 2 and it's sorted, so you're checking if it's already sorted, right? But it's also adding an overhead if you have to check it always if it's sorted. If it's sorted already, okay, it's finished, and then you can return the thingy already. So you're just checking if it's sorted already, and then you're pushing it back, and then the pivot is sorted already, and then you keep pushing it back and so on. Okay. What? Yeah, okay, you're pushing this one, and then you're pushing back even. Wait, I'm not understanding this step. So you have this temporary thingy. And this is the other quick... Ah, yeah, okay, you're pushing back this one also. So, okay, makes sense. Okay. Got it. I like the music, guys. It's so chill, right?
I'm just using a simple for each loop. So after running this, of course, our array is not yet sorted. So before we display the elements of our array...
He's doing Java. No. I want to have some... this was really good. Now I want to see it for C++. Why? Data structure quicksort. Okay, let's see. Here we go.
Hey everyone, I'm Nick from Coffee Before Arch, and in this episode of C++ Data Structures, we're going to look at quicksort, which is another recursive sorting algorithm similar to merge. Put this in order. And the way that merge sort works is that the first thing we'll do is we'll select a pivot element. In this case, we'll choose the last element. We could also choose the first element. Doesn't really matter. So for our implementation, we choose the last element. And then what we're going to fundamentally do every single time we call this is that we'll create two subarrays, one of all the elements less than or equal to the pivot, and one with all the elements greater than the pivot. And then after we've created those two subarrays, all we need to do is insert the pivot in the middle of those two, and then that pivot will be in the correct spot in sorted order. And then all we need to do is we need to take the two subarrays, and then we need to do the same process on each of the subarrays. And this will continue on and on and on until everything is sorted. So starting out, we'll compare against all these numbers kind of in a row. So we'll first look at 20, and we'll say, is 20 less than or equal to 50? In this case it is, and so we'll keep track of the index of the last element that's less than or equal to 50. So in this case it'll be element 0. Then we'll go ahead and move forward, and we'll see, is 10 less than or equal to 50? That's true. So we'll kind of progress this barrier along again. Then we'll look at 80. 80 is not less than or equal to 50, so we don't really have to do anything. All we have to do is leave the barrier where it is.
It's interesting. There's so many different implementations, right? So I'm still not sure what the rule is. Like,
because 80 is greater than. Now it's important to note that at this point, we know that from 0 to 1, these are all numbers that are less than or equal to 50. That doesn't look very good. And then at this point, since we've checked 80, but we didn't progress this barrier, we know that all the numbers between these 2 points are the numbers greater than 50. So when we get to the next number for comparison, we'll look at 40 now. And so we know that 40 is less than or equal to 50. So what we'll end up doing is we'll end up swapping these two numbers in order to be able to move this barrier.
So it seems like there's so many different implementations. But probably the best one is if you're just using the same array or whatever, and you're just allocating the thingies, right? And maybe store it, like saving it temporarily and then changing it up. I don't know. Instead of creating always new strings. Because I think it's really, or initialize new strings. Because I think it's really expensive to initialize always new strings, correct?
Over. So what will end up happening is 40 will go here. 80 will go here. We'll keep this barrier there, and we'll move this barrier forward. And so now this will be from elements 0 to 2 will be all the numbers that are less than or equal to 50. 2 to 3 will be all the numbers greater than 50. But we don't really need to keep track of this. We just need to keep track of all the numbers less than or equal to 50. But this is just, overall, the kind of state of our intermediate broken down array at this point. And then 70 right now, because we haven't looked at it yet, it's part of this kind of unknown area where it could be less than or equal to, it could be greater than, but we haven't checked it yet. So the next thing we do is we'll check 70 as well, and we'll find out that 70, of course, is going to be greater than 50. And so we end up doing nothing.
Okay, I want to see the implementation. Okay, I know what he's want to do.
It'll have to it'll continue down, and 40 will end up being put in the correct spot.
Okay.
80 will get put in the correct spot, and then eventually it'll hit kind of the base case where there'll only be a single element left in the recursive call, and so a single element will be, to sort a single element is always sorted, so there's nothing left to do there. However, with a single element that's already sorted, so we don't have any work to do there. If it's not a single element, if there's multiple elements in those subarrays.
Let me see how is he doing it. So we have void, quicksort, no return type, really interesting. Not yet. Why it has no return type? Ah, maybe he's using two. So we have the quicksort, and then we have the array, and then we have left and the pivot. That makes sense. Recursive function that partitions the array into, okay, subarrays and calls quicksort and them, okay. Then we have if left is smaller than the pivot. Yeah, then do this. Partition the array into subarrays, and then, we're creating new ones. But this is also expensive. But we're creating just an integer. It's not that expensive then. New pivot. If you're just creating a new pivot, okay. Partition, array, left, pivot. Okay. I mean, you can do it also like this. Yeah, this is way better. And then you say, okay, sort the subarray via recursive calls. And here we have the pointer to the array. And then integer left. Okay, then we're gonna say quicksort. Gonna call it again the array. Wait a second. Why is he using here? Why is he dereferencing it? That's just a type then, right? An array. I'm a little bit confused. Maybe someone can answer me the question here. So left, new pivot, and then he's going like, okay.
Go ahead and find a new pivot, and that new pivot will be based upon partition. And so partition will be what actually creates those two subarrays. And then new pivot will be whatever that pivot point was inserted between those two subarrays. And then we'll call quicksort on those two subarrays. So in the actual partition function itself, it'll take whatever the left index is, and then whatever the new pivot will be. So in the case of the first call, the left index will be 0, and the pivot will be, in our case, if we look down in the main function, we've got 10 elements in an array that we're going to sort. So pivot will be 9 because it's an array from 0 to 9, and left is going to be 0 again. So we'll go ahead and start off low as the one less than the left index, and that's because before we actually start, we want to make sure that our marker isn't already saying that 0 is included in that array that's all the numbers less than or equal to.
Because the smartest people writing their things using pointer for swap and not using reference like a normal C++ programmer would. But why are you not using references? I mean, if you're programming in a C++, why are you not using reference? I mean, please explain it to me. Algorithm people are those love algorithm. Too much, they don't know shit about the language they use. I mean, I would do also lead code for fun to get better, but there's so much, like, I mean, if I'm watching a C++, I mean, this video is 4 years old, right? But still, if I'm we have references, right? I mean, then make a video about, okay, C data structure quicksort. I'm fine with that. But if you're calling this video C++ data structure, please use the features. I mean, maybe this is also the problem why we have so much how it calls segfault. Well, the thing is, I mean, if you're using references, way more safe. Okay.
The pivot. So we put it kind of a little bit before the start of the array, just to make sure that we're saying, hey, nothing's there yet. So in this case of starting out, left for the first call, left will actually be -1, which is an invalid index, kind of signifying that nothing has been added to that subarray yet. And then the high point that we're going to go until is going to be pivot -1. So we're going to compare all the numbers up to, but not including the pivot. And then we have a simple for loop that just will go over each of those numbers, just like we did. So if that number is less than or equal to the array of the pivot point, so like I said, like we kind of looked at that drawing, we compared each of those numbers to the pivot. If it was less than or equal to the pivot, this hello plus plus is just moving that barrier along. And then we'll go ahead and swap those elements and
Do you know that the plus plus is also triggering me now?
put them into the correct position. Then finally, after this is all done, then we can just go ahead and put the pivot into the correct position. And so the pivot will be just past that.
I mean, they're getting the job done in a really good way. But I don't want to imagine how a big project is looking like. Like, oh, someone knows the language. Someone is just super smart, right? Doesn't know the language that well. And then everything like mixed up together. Ooh, nice. What is stud span? 1 second. Okay. I just decided, I think I'll bring it to the end for today. And I'm just trying to code the better version off stream. And I can present it then to you tomorrow or something, right? So we're doing tomorrow again quicksort and not quicksort, we're going to do a quicksort. But just a better version. If you have a really good quicksort version or a good video about this topic, please feel free to share it in my Discord. And yeah, I think that's it for today. Thanks a lot for the support. It started today a little bit. How should I say it? Not even have the correct word for that. But I'm out. Thanks a lot, boys.